Okay, now we're back. I need to remember what I was doing for. Oh yeah, we are copying the type neural array functions into CUDA, making CUDA versions. Now we need to where we're at what point we're before. Okay, set data. Oh, there's an error here. Get data. Fill 0, fill 1, subtract, add, divide. Oh, we're gonna have to remove reverse. It doesn't serve any purpose here. Okay, where are we? Get mean squared error. Okay, just copy it, and then we're going to translate it into CUDA version. Okay, now let's copy this right here. All right, get mean squared error. How do we get a mean squared error? Let me just copy the kernels. Well, I prefer this one. Results target. Okay, now we're going to copy everything and see what gives. Okay, get mean squared error. Copy the name, kernel, get mean squared error. We have a source, we have a target, and yeah, we don't need this. Target length. Okay, let's replace CUDA neural array with type neural array. CUDA neural unit. CUDA neural unit. Change the name. Okay, now we're ready. And change this. CUDA neural unit sum. Okay, the sum goes up here. Sum goes up here. Okay. Okay, sum equals 0, 4. We take the for loop and then we. How do we do this? Okay, it's not really that simple anymore. Just to replace the for loop with a kernel function, because getting the mean squared error is somewhat more complicated than basic stuff. You can't just copy and paste there to get things to work the same, because you have to understand how the function works. Because sometimes you need in order for the kernel to work, every part of the function, like every piece of data it works on, has to be separate. But for the mean squared error, all the pieces of the array are connected. So you have to copy the entire for loop inside the kernel. You don't get any speed up with get mean squared error. The only reason that you use a kernel is because you are operating on data that's inside the GPU, so you can't just use a standard function. Okay, length. We just copy the entire function, and we just do inside the kernel. Parent, not result. Source, result. Is it result or source? There's no result. No, source. Oh, now we have another problem. We're gonna deal with it later. Source. We have another problem, and this one's gonna be a big one, but let's deal with it afterwards. Target.array data, source.array data minus target.array data. Is it source? Just value. Source.array data, target.array data sum, and then if sum. Now we get into the problem. Almost there. Length equals length divided by length. Oh, that length is never going to be 0. Okay, result equal divided by length. Oh, unless it is 0. Actually, it could be 0. Let's not take any chances. If length is more than 1, sum equals sum divided by length. Okay. Now we get to this last part right here, and this is a problem, because global functions have to return void, because you cannot return a value from a kernel. Because there's usually many of them, and you can have them return a value. Also, you cannot return the value in the normal way. So it means that you have to do something very, very special here. Okay, let me look it up and see what that means. Okay, this is how you do it. You need a variable that is visible from both both the GPU and the CPU. So you have to copy it from GPU memory into CPU memory. But it has to be done automatically. So the name of the variable is managed. Managed. Underscore managed. This tells the GPU that this variable right here is visible in both the CPU and the GPU. Managed just means that whenever you write to it, the system automatically copies it from one to the next. I'm not really sure if it works both ways or one way, but it works backwards. So you can copy it into. Actually, it does work both ways. Anyway, if you copy a variable into this, it will just copy it back and forth between them. Okay. What do we call it? CUDA neural units. Manage CUDA neural units. Let's choose a name. CUDA register 1. That's just a name I chose. CUDA register 1. CUDA register 1. And then we just copy CUDA register 1. Copy the value into CUDA register 1. Okay. So that's what you need to remember here. Manage the variable type and the variable name, and then this lets you copy data back and forth between the GPU and CPU. Okay, that should be it. And one more thing. We need to copy this. Kernel reverse. No. Not equals source. I'll just change the name. I didn't choose my names better because otherwise it gets really complicated. Okay, source plus per grid. Okay, since we only call it one kernel, we set this to 1 and 1, and let's just copy the name. Don't forget that. Result, not result. Source target source. And now for the last part. Not return device synchronize. You cannot just return device synchronize. Okay, so now that we call the kernel and it has finished, now we set the result. This is a bit more complicated than the others. Okay, like I said, it copies it set register 1 to sum. Do the value here. Whoa, that doesn't work. Okay, that doesn't serve any purpose because there's only one kernel. We only call it one kernel, so you don't need to know any of this. For I equals 0, I less than length. Of course initiator. No, oh wait, we're not using this. Did I make that mistake before? Kernel fill random. No, I don't. No, I didn't. It works. I just have to remember to call a kernel, call just one kernel. Why do I even need this? I actually don't need this. In the random one. Since I'm not using that, I can just delete this part right here. We don't need that. Just call the kernel one single kernel and we're done. And then we synchronize. Not that we need it, but as a habit, you should have it every single time you call a kernel, just to make sure. Okay, kernel subtract everything's right. Get mean squared error, and kernel mean squared error, and it set CUDA raised to 1, and result equal CUDA raised to 1. Okay, so this part's done. Next part. This index map copy. It's a big one. Oh, this is a big one. Index map copy 2D. Okay. This is going to hurt. Okay. Kernel index map copy. Kernel array, not kernel array, yeah, whatever. Okay, that's not a kernel. Static void. Okay, where do I start? It's gonna be painful. CUDA neural. Step one, just copy all the names. But there's a lot more to this than it looks. Oh, this is gonna hurt. Okay, CUDA neural. Okay, just figuring out what to do with this one is gonna be painful. Type index map or CUDA index map. Okay, there's another problem. Another huge problem. Type index map. Oh, this is gonna be painful. Because the index map operates in CPU memory, you have to make a CUDA version of the index map. Okay, so you can't just use index map. So now you have to make a CUDA version of index map. Oh, okay. So let me get the original version and we copy it. Okay, we're gonna have to create a different version of CUDA index map. Because the index map that we're using so far only works inside it only works inside CPU memory, the main memory, and we cannot modify index map out in GPU memory. So you have to create two separate versions and then create a copy for CUDA. So basically, we have to create a new file here. Okay, I'm not gonna create a separate file, so I'm just gonna make it a right down here. If and def. Just copy it. Okay, no, wait a minute. If and def. No, what am I doing? Is it tweet? Yeah. If and def CUDA index map dot h define CUDA index map and if or and if. Okay, copy it and paste. Okay, now we need to create a create index map long CUDA index map. Let's copy the name. CUDA index map create copy. Okay, CUDA index map. No. Let's call it create type copy. Create type copy. That's better. Parent. No, parent. CUDA index map. No, type index map source. Type index map source. Okay. If parent equals 0, double equals 0, or source equals 0, return 0. Okay, index map. Let me just copy from index map. Okay, now from index map, we need to copy everything here. Actually, no, we don't. No, this is completely necessary, but oh wait, no, not yet. I completely forgot. We have to copy down here. No, wait. Whoa! Did I copy this? All this work and I haven't copied the most important part. Okay. I need to fix this. I need to so fix this. Couldn't type new array. Before I even continue, I need to fix this. Oh, all this work and I haven't. Whoa. Oh. Actually, no. Type shape 0. Okay, type shape assign. Yep. Oh, I forgot to do all of this right here. Type shape 0. Type shape assign. Oh, actually it's good. It looks bad, but it's actually good. Okay, that scared me. I thought I missed something. No, type index map. Oh, we have to copy the name, because otherwise it's just going to complain. Okay, copy the name, type shape, type index map. Okay, okay, good. Source dot index width. Just copy and paste. So index width. Okay, just copy everything here. I don't have to copy everything. Oh no, the last part is data. Oh, what am I doing? I keep forgetting that I'm supposed to allocate the memory. Unsigned long data. Unsigned long. Okay, step 1. Allocate the data in GPU memory. I'm confusing myself here. Allocate data in GPU memory. Step 2. Well, we have to, before you get step 2, is you have to source dot index size. Source dot index size. Allocate data in GPU memory. And step 2, we set all variables to being identical. Height, length, and size. Okay, return. Okay, step 2 is copy memory. CUDA memory, allocate memory, CUDA memory, copy the memory, set device memory. Copy the memory from the from the CPU to the GPU memory. Okay, data. Is it data? Yeah, data. And source dot array size. No, source dot array data. Source dot array size. Okay. Step 2, allocate the memory. Step 2, copy the memory, and step 3, set everything, set all the variables to right values. 0. We have to hold the memory somewhere, because since that's why we need a separate structure. Okay, and we haven't done any of the hard work yet. This is just housekeeping stuff. It's going to get really complicated really quickly. Okay, index map destroy. We're just preparing for the hard stuff. Okay, copy. Okay, CUDA memory, free memory, parent dot index data, and return 1. No, return 0 here. Okay. Now we need to copy all this outside into CUDA library.h. The system needs to be able to see it. Okay, let's copy all this. No, cut, not copy, cut. CUDA library. Let's put that here. And then copy all the function names. Create and destroy. I have to fix a lot of things here. The other export. And then, okay, so far so good. Index map here. Include, no, just save it. Do the include. I don't know if I did. Okay, include CUDA library. This is completely not necessary, but I just pretend that we need it. Okay, so this part is good. Now, let's get back to the difficult stuff. This is going to be difficult. What was I saying? Okay, now the next keyword. There's manage, there's global, and now there's device. Device just means that this function here exists inside the GPU. It only operates inside GPU memory. Since it does something very specific, we don't need to worry about it. Just set device. This part right here is simple. Now we have to get into kernel. Well, index map, copy to D. Index map, copy to D. Okay. It's not actually a kernel, so that doesn't matter. Okay, now we get into some really complicated stuff. Do we need this? No. Let us copy everything. Okay, get rid of this here. Okay, again, this is just to visually let me know where kernel begins. Okay, kernel index map copy. Let's keep the function in the same. Index map copy. Oh, I need to change the name. Kernel index array index map copy. Just change the name to something. I can actually array index map copy. Or just index map copy. Index map copy. Just to keep everything clear. Okay, next step. Take all of this here, this for loop right here, and then copy it. Now cut and paste. Oh, wait, we don't need the for loop. Okay, we don't need the for loop. Okay. And it's not that simple either. Because we have to know exactly what the function is doing. Okay. Wait a minute. Array depth. Yeah. We have to know exactly what the function is doing. Parent.array data. You can't just copy everything without knowing what each thing's doing. Result. Okay. There's still a for loop here. Oh, there's another problem. Oh, it's not really a problem. One more thing. We have multiple for loops here, but they're all necessary. Oh, actually, they're not. Wow, this is more complicated than I thought. I thought it was complicated, but it's actually more complicated than I thought. Okay, now we have to do a little bit of surgery here. Take this for loop here, and then move it out into cut. We have to move it out down here. For each kernel. Actually, we don't need to move it out. It's not a for loop. We're just getting rid of the for loop. If I equals 0, everything here is exactly the same, except for this part right here. Array index source, not index data. We have to copy index map values somewhere else. Okay, so we have to get rid of a lot of things here because oh, this is gonna be complicated. Result. Let me just figure this out. Oh, now I remember. Okay, we have to figure out from here. This is the type version in the CPU version. There are multiple for loops here. One is for each slice of the image, and the second for loop is for each individual pixel of the image. It's more complicated than I thought here. Okay, so now we need to work out where we are. We have to remove this for loop right here. So we need a two-dimensional array. Okay, let's start from the bottom, right here. Okay, let's start from the bottom here and copy this. Now we need by 16 by 16 because we need two separate loops, blocks per thread, and that's the X version of the for loop. Now we need the Y version. Okay, this is a complicated one. Okay, X, replace everything result.array length, no, array depth, result count, no, result.array depth, I think, yeah, depth. Okay, parent length, source length. Why do I need this here? I made a lot of things more complicated than they needed to be. Rename things. Okay, result. Let me just retype everything from scratch, because this right here I did it really quick and dirty. It works, but I wasn't really thinking about optimizing. Let's just copy everything just for CUDA here. Okay, parent length. Let's name this result. No, parent length, result length. I'm just going to retype everything, start from scratch, and then just redo everything just to make it work better for CUDA. Okay, not type CUDA neural array. CUDA neural array index map copy to D. Okay, result CUDA neural array index map. Yeah, get rid of all this. Index map, kernel. Okay, result length. Result length, result count. Before I didn't really know what I was doing when I typed this. So let us redo everything. Result.array shape dot array depth. Okay, this is size of the image. This is the number of images. Result count. Source length, array length, result count. I just didn't know what I was doing. Okay, so let's just do it better. Count. No, not. What am I doing? Result count. I'm not thinking here. Source count. Number of images. Size of each image. Result length. Result count. Source count. Equals. Not parent. Result. I had to rename everything to be more consistent. Result source dot array shape dot shape depth. Okay, if index map dot equal result length, and return 0. If source dot array shape dot array depth, not source array shape dot array depth, source count. Source count. No, result count not equal source count. Return 0. dim3 16 by 16 result. What am I doing? Result. Yeah. Result index map. Okay. Result. Source per grid. Am I typing this right? Result length. No, not result. Result length. If result length not equal threads per block, thread ID. Threads per. What am I missing? Oh, threads per block. It's right there. It's right here. Whatever. Okay, result count. Okay, unsigned long result count. So what's the problem? I don't know. Let's get rid of all this. Will we retype it after? Or will we? Doesn't matter. Okay, kernel. No, not kernel reverse. Threads per block. No. Oh, you have to get this right. It's X and Y. Okay, what am I missing? We copy it after. Okay. Oh, there it is. Okay, no. What am I doing? Dot array depth. No, shape depth. Oh my goodness, shape. Shape depth. Result. Make sure you get this right. Result, array depth, kernel. Okay, now let's write the kernel. Let's just copy it back. Okay, let's just copy everything back. What am I going to call it? Okay. Okay, what do I need? Okay, type thread.idx. Just make sure I got everything right. Type neural unit, CUDA neural unit. Yeah, it doesn't matter. Okay, just make sure everything right. We are in I and a J. I, J. Y, Y, and Y. Just make sure everything right. Length. Okay. If I less than what? Is it result? No, result length. Result count. Result length. Result length and result count. Oh, what do I have in result count? Let me remake this. Source, index width, index height. Or source, no, CUDA. Why is it complaining? CUDA kernel array index map copy to D. Yep. CUDA. Let's make sure I have everything here. Index width, result index. What do I need a result index? It's inside the thing. I don't need that. I don't need that here. Source index, we don't need that here. Result length and result count. Because now we're transferring everything inside the kernel. Source count. Source count. Okay, this is gonna be really complicated to make sense of this. Okay, result count. Trying to keep track of everything here. Result count. Okay, now where are we? If J less than result count. Now where are we? Now we need to figure out where we are exactly. Now we don't need the loop. That we're inside this. Okay, sum equals 0. No. Unsigned result index. Now we need result index. Unsigned long result index. Okay, this is the current image that we're working on. And result index equal what exactly? Equals J is the result count. So this tells us which image we're on here. J times result length. Yeah, result length. That's the size of each image. And now we need which image? The source image. Now we need the source image. We're copying from one image to the next. Each one of these is a loop. I keep thinking in terms of CPU and again. Unsigned long source index equals J times source count. Okay. Okay, now what? Okay, now we have a matching image. We need to copy between them using the index map. So how do we do this here? Do we need counter? We don't need counter. Why did I need counter before? Index map copy. What? Oh, we're summing up and we need to. Oh, we do need counter. Oh, we need counter. Oh, we definitely need counter. Okay, counter equals 0. I just can't remember why I needed counter. For I equal index height. No, for j equals index height. We don't need the j anymore, so we can really use it for something else. We need the k here. I could create another variable. We don't need j. Okay, for I equals index height, and we do this and this and this. Source, the source index plus index, counter plus plus, kkk. If count equal 1, or everything here. Result index plus I. Result length. Everything's the same. We don't actually need to change anything. We did it. Everything's exactly the same. The kernel takes care of the looping part. We don't need to change anything. Everything is basically the same. Down here, blocks per grid, blocks per block, but we still need to copy all of this right here. Same as before, but slightly different. Index map plus blocks per grid. Let's move everything down here. And just so we know what we're doing, result dot array data. Okay, result dot array. Okay, it's a bit complicated because we have to match everything to the CUDA version, because a lot of things are the CUDA version creates a loop in here. It turns every bit of the function into its own loop. So the original loop right here has to be removed, but it has to be removed in a way that's very different from the way I did that right here. So it's two loops: the I for I equal shape depth, and for I equal index width. So it's two separate loops. Now the way I did it here is somewhat weird. Actually, it works for here, but when you have to translate it to code, it just creates something very, very different. So that's why I have to modify all this stuff. That's kind of a mistake, but yeah, it's good enough. Okay, index width equals, okay, index map, index map dot index width. Index map. Oh, is it type index? No, CUDA index map. Ooh, CUDA index map. Do not get this wrong, because if you get this wrong here, everything will just crash. CUDA index map index width. Index map dot index height. Okay, index map dot index data. Index data, result length, that's right. Result count, that's right. Source length, that's right. Source count. Okay, again, the way I did it for the CPU version and the way I did it for the GPU version are slightly different. That's why I have to make all these modifications here. But so far so good. Everything seems to work. Can't be sure until we test it, but doesn't appear to be any errors. Everything's basically the same. If counter more than one, result index equals sum. Okay, now you have to copy the device synchronize, and we're done. Whoa, that one really messed me up. Took a while. Yeah. Okay, did I get everything right? Yep, kernel index map copy. Okay, let's clean this up right here. Advanced format document. Okay, so let's verify everything. So everything we needed for copy, it works fine. It seems to work fine, I think. I don't know if I should test this right away. Okay, I need to figure out test this thing. Let me get back. Okay, slight error, very slight error. We already declared I, J, and K here, so get rid of that. Just to be consistent. Okay, that should do it. Let me just rebuild and see if it works. Okay, well, go. So far, so no, it doesn't work. And another huge error. I forgot to call this one a kernel function. It's called global. I use the term static, but it's not static, it's global. This is something you need to remember. Kernels have their own rules. Let's rebuild again, just to make sure it works. Okay, come on. Yeah, it's good. Okay, now let's copy into CUDA library. Divide. Oh, I didn't copy any of it. Okay, divide. Okay, anything else I'm missing? And mean squared error. Okay, mean squared error you have to copy. and then divide. Okay. Okay. I'm sure I missed something, but we don't need to worry about it until later. DLL export. Okay. Now I'm going to come up with a way to test this. I was just creating a test for this, and I realized I made a huge mistake somewhere. Let me show you. Here. Index map create. Instead of use it's a rotate 2D, but I'm using the entire shape length. I made this mistake where right here, scale 2D. I made this mistake before, but I forgot to change the rest of them. In zoom, that works right here. Actually, that doesn't work. Let me check it. Oh no, zoom it works. Shift it works. But everywhere C2D, you have to change it to width and height only, because otherwise it will not work at all. Oh yeah. Just a really stupid mistake, but easy enough to fix. Let me just fix it. Okay, I was looking over this and I found one tiny error here. Is J times result length, not result count. No, source length. It's a minor error, but it should work right now. Okay, so it works. It's a bit slow because we're doing a lot of really strange things here. In order to test it, I'm doing something weird. I'm creating an index map, copying it into the GPU memory, and then deleting it. Which is okay. The next thing you have to know is that copying back and forth in GPU memory is something you really shouldn't be doing because it's very, very slow. So that's why it appears to be much slower than it should be, and it's jumping back and forth. But that's just for testing. All that matters is that we know that that everything works. That this part right here, the kernel part, it still works. So next time we're going to do convolution and pooling, but now that we know this part works, should be very easy. That's enough for tonight.